Yeah, thanks for joining us. My name is Andrew Mander. I'm with DIAMANTI, and I'm just going to try to run you through a lab as quick as I can. I know we lost some time here trying to get on the Wi-Fi, but so what DIAMANTI is we're the only purpose-built container appliance on the market today, end-to-end, and we have Docker and Kubernetes built in, along with our specialized network and storage controller cards. A lot of the folks that founded DIAMANTI came from Cisco. They built the Cisco UCS product, the original architects and engineers. They were part of the Nuova Systems group. They came over, decided to do something different, left Cisco, and they're like, hey, let's build a converged device that that caters to the container workspace, right, the container world, and let's do it without a hypervisor. Let's build in like native enterprise constructs for network and storage and compute and things like that on Docker and Kubernetes, and that's really what we've gone ahead and done. So let me just run you through some really quick visuals here, so you sort of have an idea as to what you're looking at as I go through the demo here. So at the end of the day, DIAMANTI is a container-based appliance, and that is not happy. So let me show you a quick picture of it. And, oh, sorry about that. Switch There we go. So I'm going to do it in non-full screen mode here so you can just sort of see it. So it's basically a 1U box, right? At the end of the day, it's running Intel hardware, Intel motherboard, Intel CPUs, Intel NVMe, Intel end-to-end, where we add our special sauces here in the network and storage controllers. So these are the hardware endpoints that were developed by the DIAMANTI engineering team, and this is really what they look like, right? Our little network card here, storage controller card there, and this is what enables a lot of that functionality at the container level that's native to container constructs, like for example, layer 2 networking, SRIOV, persistent storage, snapshots, volume replicas, the ability to have multi-zone configurations and distribute your mirrors to other zonal spots, like so other data centers for HA, for DR, for data protection, all that. And these are things that are sort of missing from the Kubernetes and Docker experience right now. A lot of folks are used to doing things, again, through host path or shared file systems like network file systems like NFS and things like that. But we're doing all of this at a block level, under the hood, low level. And so DIAMANTI years ago helped to develop actually develop the Flex Volumes framework for Kubernetes, which is what allows us to plug in these controllers into the Kubernetes ecosystem. So Flex Volumes is a part of the Kubernetes project. It was built by us. It was submitted to the Kubernetes development community, accepted, merged, it's part of Kubernetes code. And so we plug this into our endpoints into all of this. And our customers, or we have partners such as Red Hat. Red Hat also uses Flex Volumes for some of their products like OpenShift. But as time progresses, a lot of the Kubernetes folks are moving more towards the next generation standard called CSI. It's still not quite there yet. It's a bigger tent. There's a lot more vendors. And so it takes a little bit more time to do things. And so a lot of these things that the enterprises need now, we're doing today. So, and that's because of these network and storage controllers that, again, we built ourselves. And a lot of that experience building UCS has gone right into this, like for example the concept of the VIX and things like that. So you'll see some similar or familiar concepts, as I go through this, right? Why did we put this on hardware? Because there are things you generally can't do outside of hardware, right? So for example, we can hammer the nodes with a really high load average, like say 20, for example, right? And we're still able to give sub-millisecond latency to your storage and network endpoints. So if you look at the load average via top or any of your performance metrics, you'll notice that even when the machines are completely hammered on all the cores, that you're able to maintain really, really consistent low level or low latency performance. So let me get quickly into what it is or how this all comes together. And I apologize, there's a little bit of latency here. Let me make sure that this is all working. So I'm on one of the Diamanti nodes right here. It's called, this is SE41. There's 3 nodes in this cluster, and we try to make sure that there are a minimum of 3 nodes for quorum purposes, because in Kubernetes you want to make sure that if one of your machine dies, then the cluster configuration lives somewhere, right? So we have 3 nodes in play, node SE41, 42, 43. I'm logged into 41. Most folks don't administer this by logging into a server. They do it from their laptop or desktop or whatever. I just sort of do it a little bit dirty-like and do it on the node here. So let me build a cluster. So before I do, I just want to show you that we're actually running Kubernetes. And this should fail, hopefully. You normally don't hear people say that when they're doing demos. So we're not connected here. There's no route to host. Kubernetes is there. It's just not running. If I looked at the process list, right? See that there's no Kubernetes processes running, and so it's, they're basically dumb nodes. So this is the state the nodes would be in if you got them in your data center, you put them in a rack, you powered them up, you put IPs on them, and they're just sort of sitting there. They're just dumb nodes, right? And just to show that this isn't a simulator or anything weird, right? Let's just look at the hardware here, so you can see these are actually. I should probably make it easier to see here. These are actually Intel boxes, right? You can see the Intel serial numbers on the Intel motherboard. So these are like real systems, not virtualized sandbox environments. So again, completely stock set of Kubernetes, Diamanti-based Kubernetes nodes here. And let's get up and running. So I'm going to build a cluster right now. And I'm going to do aliases because I am a terrible multitasker, so I'm just going to let it do its thing, and I'll explain what it's doing here, because I can't talk and type at the same time. So it's building a cluster out, and so you can see we're building the cluster with the dcuddle command here, which is Diamanti's command line binary, and we're telling it to create a cluster called SE4 demo. We're inserting 3 nodes, those 3 Diamanti nodes, SE41, 42, and 43, and you can also do this from a web interface, and I'm just doing it from the CLI because Wi-Fi. And the VIP here is the management interface. It's a floating management interface, so you can just hit it all the time. You don't have to go to a specific node. Here's the DNS subdomain, so you can keep track of your hosts from a cluster perspective. Storage VLAN, this is what we use to do volume replication, and the volume data goes over the MVM over Ethernet fabric and replicates into other cluster members. And then you have the super secret Diamanti password here. And then I wrapped it in the time command, so this number changes all the time. But it took about 14.9 seconds to build the cluster, right? And so it did one more command, which is log me into the Diamanti cluster. So pointing it to the cluster VIP, here's the login username, the password, and there you go. So now let's look again for the Kubernetes services. They're now fully functional. They're up and running. And I can do, let's look at Kubernetes itself. Kubernetes is actually running, right? Here you go, no errors. And there you go, fully functional Kubernetes cluster up and running in about 15 seconds. And that's really one of the things that we've done at Diamanti, right? We've tried to get people from a place where they need containers, because it is a bit of a challenge to get all this up and running, especially if you are trying to productionalize it. Because there's a lot of folks that are like, oh, I got Kubernetes up and running on my laptop with Minikube, I got Docker up and running, why do I need an appliance? Like, tell me, right? So it really boils down to productionalizing it, right? Because that's like, and I know a lot of folks here are familiar with VMware environments. It takes time to build that out. You have to, your ESX host, you have vCenter, you have all the infrastructure building blocks that are necessary to get a production infrastructure environment up and running. And that's like someone coming up to you and saying, hey, why is VMware so hard? Like, I got VMware Workstation or Fusion running up on my laptop, and that's different from productionalizing it, right? So we try to integrate a lot of those production components into the product on day one. So we get you from that need, technical or business, to containerization faster than anything else, because we provide the end-to-end solution. And you hear that a lot in the Kubernetes world, like we're the end-to-end solution, but we actually are. So we provide the metal, we provide all the CNI, CSI, like the storage and network plugins that you need for enterprise uses, to operationalize this. And these are all things that are provided on day one, and we give it to you in 15 seconds, right? And it's pretty easy to add nodes. You just basically go into the web interface, and I'll try to pull that up if I have time, and show you what it's like to insert nodes. It's pretty straightforward. You just click a few buttons and off you go. So again, 15 seconds, Kubernetes cluster up and running. There is one thing we have to do to get some workloads going, and that's that we have to assign IP addresses or set up IP addresses, right? So that same command line binary that you saw earlier, dcuddle, which was used to create the cluster, we are now going to use it to build networks. So I'm doing dcuddle network list. There are no networks in place, and so if you do anything in Kubernetes, it's just going to complain, I have no networks. So let's set something up. And so I'm going to do a lot of aliases here because, again, can't talk and type at the same time, so I apologize. So here we go. This command basically this alias did three things. It did dcuddle network create default, and that's just an alias. That's a namespace name, and I just called it default. Here's your subnet, your start and end IP addresses for this namespace, your gateway, and your VLAN. And this is, for those of you that have worked with Kubernetes and know what it's like to set up networks via the YAML or JSON files or Flannel or Calico or whatever else, this is plugging into the same CNI backend, but we're trying to present it in a way that enterprise operators can sort of adopt this quickly and with a construct that sort of makes sense to them, right? Instead of like a 500-line object file, which is not, that sort of configuration syntax isn't really, or a command of it isn't really common in the enterprise space. So especially for traditional operations folks. So I created another one here called Blue, and then a last one, the default network namespace here, I just told it to become the actual default network namespace. So if I do dcuddle network list, you'll see that we actually have two networks now. So I'm going to start building Kubernetes workloads. So I'll do Nginx first because that's pretty straightforward, right? Web server, load balancer, everyone knows it. So I'll do kubectl. And after you set up the cluster, after you set up your networks, you can pretty much use only Kubernetes commands from that point forward. So that even applies to making requests for volumes. Kubernetes can make a callback to us. We carve up the volume and hand it off back up to the Kubernetes workload, and that's all done transparently. So let's just do kubectl run, and I'll just give it a deployment name. I'll just call it Nginx Diamanti, and I'll pull the Nginx image off Docker Hub here, and I'll do set a replica count here. I'll do 6, right? So there you go. So I created 6 replicas of Nginx, told it to pull it off the Nginx, pull the Nginx image off the Docker Hub repo. It's the latest tag. I mean, you can put a colon in there and have specific versions and things like that. And this is all standard Kubernetes syntax. This isn't anything that we're doing differently. The difference is the speed in which we do it and the ease of consumption of I/O endpoints, because you're not sitting there having to configure everything and tweak the knobs just to get the most basic of network interfaces and to get persistent storage with the ability to do things that you expect in the enterprise. Again, snapshots, volume, replication, link clone volume, exporting the storage objects into like S3 buckets, NFS targets, things like that, tarballs. So these are all things that are done out of the box. So you can see now we have 6 instances of Nginx running, right? Pretty straightforward. We just did it with one command. And if you want to scale it up, and this is the reason why people one of the big reasons why people use Kubernetes, because you can scale, right? And this is something that isn't really doable with virtualization, because the virtualization, as you know, is the emulation of hardware. So you have to boot the entire system up, and then the OS loads on top of it and all that, unless, of course, you pull out of, pull from stateful images and load those up from as sort of like an unsuspend mode with VMware. But let's do this. It's essentially, whoops, it's already running. Scale deployment Nginx Diamanti, and let's set the replicas to say 50, right? It'll go ahead and do that. And so now we put in a request to the Kubernetes scheduler to have 50 instances of Nginx up and running. Let's look at it. And in about 30 seconds, you'll have 50 instances of Nginx. They're all independent. They all have their own IP addresses. They're all pulling from that network namespace. And this is applicable to not just web services. This is applicable to databases, CI/CD pipelines, pretty much anything that's an x86 application, right? The only, at least in this iteration of it, Linux-based x86 application. The only things that don't really run under containers are things that need direct access to hardware, because the container runtime environments prevent that from happening, and when things need to insert and eject from the system kernel, right? So, but pretty much everything else runs under the container umbrella. So you can see we have all of our instances of Nginx up and running here. So sort of neat, the power of Kubernetes, and then combined with Diamanti. And so you can see how you can get fully functional production Kubernetes environment up and running in minutes. So, so just wanted to make a quick note that, as Diamanti here, we're located in booth 614 down the way there. So if you want a little bit more of a deeper dive, we can help you with that. Also, there's a talk later at 3:40 in Great America 1, and that's a talk that I'll be giving, and it covers sort of the challenges that traditional enterprise operations teams have when getting into the world of cloud-native workflows with Kubernetes and things like that. And there's definitely a culture clash at the enterprise level that a lot of people don't really talk about. So we'll be discussing that. So, but yeah, thanks for your time.